data. There's no data. Why would this possibly? What happened? Okay, not sure what happened there. Can I? God's sake. Okay, we're having a great time with this. We're having, yeah, I know. The second I said that we've had so much more luck with YouTube compared to Teams, it instantly started going wrong. I think we probably could have predicted that. We'll try it a bit more. I'm connected now. If it goes again, I'm going to go things and we'll have there's an unplug and replug the router and see if that's the one that's at fault. So let's see how long this one lasts. Yay for computers. Okay. Now I'm going to go restart it. This is appalling. Okay, one more try. Haven't restarted yet because that takes forever, but I've unplugged everything else that might be using the internet and might be slowing it down. So let's see if I have a bit more luck with this. Right, so first thing I want everyone to do, because of all these delays and all the buffering, you're probably quite a long way behind the live stream now. So on your YouTube video, could you make sure the sort of red dot on the bar at the bottom is dragged all the way to the left? Make sure you've to the right. Make sure you've caught up fully and you're getting the latest stream, because otherwise there's going to be a very long gap. Okay, so hopefully we've done that. Are we all here? Can we all see and hear me? Yeah, it seems to be, this connection seems to be stable. I probably shouldn't say that because the second I finish saying that, it's going to go. But at the moment, things seem a bit more stable, so we should be able to carry on from here. Right, so just checking. We've only got 12 people currently here. Have we lost everyone? Right, okay. Well, I'll get us started, and then once we get on with the activity, I'll do the register and see who we've lost. Yeah, I'll edit down this stream to start from this point so people can watch it later if they weren't able to do it right now. Okay, yeah, seems stable. Okay, so as I was saying, I don't know how much you managed to get last time before it died. So as I was saying, I've marked all the Unit 3 end of unit tests. You're welcome to go in there and have a look and see what score you got. I'm very pleased with the vast majority of people. Only one or two people had difficulty with that, and I'll catch up with you guys in the next couple of weeks. Yeah, so you can have a look at those. We're not going to do the where I give you the mark scheme, mark that yourself. It's less useful for this unit because it's just the answers are right or wrong. There's no sort of confusion related to the mark scheme for that. So using the mark scheme is no real benefit. With this one, we'll go back to that technique. So I'm going to start on Unit 4, which is software. Now, full disclosure at this point, this will be everybody's least favourite unit by the end of it. It is every year. Nobody likes software. There's not much we can do about that. The content is very dry and there's an awful lot of memorising stuff. We start off quite interesting, but it does become quite difficult as we go through it. So if we're doing this one and you're thinking, I'm out of my depth, don't worry, everybody is. This is just one of those units we get through, we get the best we can out of it, and then the rest units go back to being fine again, but we do just have to grit our teeth and get through this one. So don't feel deflated if you're struggling with aspects of this unit. Nobody likes this one. We'll just have to do what we can with it. Okay. Right. Yeah, we've still only got 13 people. I'm just going to email around the new link one, make sure people that are trying to get there can. Okay, so fingers crossed a few more will join us now because I've just emailed round what's going on. Okay, so we're going on to Unit 4 and we start off with this part here, which is levels of computer language. And it says you need to know the characteristics and purpose of high level and low level languages. Tells you a bit about them. This is the wording directly from the specification of the teacher's guide that the exam board provides. So this is kind of the wording they'll want us to say. It says in here, low-level programming languages do not resemble natural languages such as English or Welsh. They put Welsh in there because they are a Welsh company. They're made up entirely of bit patterns, instructions or data that can be executed directly by the CPU. Whereas a high-level language is a programming language that allows code to be written, which is similar to natural human language such as English. Well, we'll look at that in a little bit. The thing is, we've used lots of high-level language. We've done Python. We haven't done any low-level programming. So before we do any more on the theory of it, we're actually going to do a bit of low-level programming so we've got some experience in it. It'll make life a bit easier. Okay, so okay, is this working? Yeah, it seems to be. Oh, it's loaded twice. I'm having no luck technically. Get rid of that bit. There we are. Okay, so there we are. So a quick starter. This is while I do the register, because we've obviously got a lot of people missing this. I need to know who got stuck with it. So as people arrive, we'll do that. Quick starter. Just write down somewhere, anywhere, as many different programming languages that you can think of. Now, some of them we've used. Things like Python is a programming language. What else? Just write it down somewhere, anywhere, notepad or something like that, and then we'll see how many we came up with. Some of them you may have used, some you may have just heard of, some you might think, is that a programming language? Write it down anyway, we'll find out. So to give you a minute or two on that while I get the register sorted out. Yeah, people are joining us now. Okay, I'm set up to do the register. Could you make sure, if your name is your username, that's fine. But if you've got a username that we wouldn't know who it is from there, could you make sure you do a post with your full name in it so we can see who you are? I think most of you I know now anyway. So, yeah. Have we got Will? I'm not seeing William, I don't think yet. Oh, yep, there you are. You are in there. So I've got Will. Isabel. Yes, we've got Isabel. Jake. Yep, Jake's there. Elom. I've not seen Elom. Normally is the most chatty person on here. So I don't think he's there yet. Thomas, I've seen. Heath, are you there? Don't think I've seen Heath yet. Paige. Dreadblocks, who's that? Saying this is me is unhelpful. Who are you? Elom, thank you. So Elom's here. Heath's here now. Paige. Sure, I've seen Paige Costick yet. Sean. Tell you what, I'll go through and fill this in afterwards because we've wasted so many times with technical problems. Let's just get on with the lesson. Right, okay, so listing different programming languages that we can. Whoops. So if you post in the chat now, what different programming language did you manage to come up with? I'll give you, we know Python, we've used loads with that. What else? Anyone else come up with different programming languages that they've heard of? HTML, that's a markup language rather than programming, but yes, it's just about, we can get away with that one. Java definitely is the right one. Assembly, Python, JavaScript, C++, something, that's one very big complicated one. C++, HTML, JavaScript, Python, Java, yep, they're all good. Ruby, impressive. PHP, SQL, Swift. Great, yeah, we've got some going in there. Now, the interesting thing is, with the exception of one person, everybody has listed what's called a high-level language. So far, we've used Python as our main language, and you may have previously done some programming in Scratch, and some of you may have experimented with JavaScript, but all of those are high-level languages. And high-level languages all have certain characteristics, but there also exist low-level languages, and the vast majority of you will not have any experience at all with low-level languages. So before we're able to look at the differences, we need to actually have some experience of low-level language, which will make life a lot easier. So we're going to use this thing called Little Man Computer. It runs in a website. It's a little simulator of some assembly language. There's a link on the VLE to it. If you search for Little Man Computer, it will be the top link that you get. And we're going to do some work with that. So spent ages doing this transition, so please feel free to go, ooh. I'm going to jump on inside the screen and we'll have a look at it. Okay. Right, so for this little man computer that we're going to do, we are going to start using the type of commands that a CPU actually executes directly. If you remember back in Unit 2, when we did things like the fetch execute cycle, when we looked at how a command can put something into the accumulator, then another command will send it to the arithmetic logic unit to add it. All that stuff is done in assembly, and that's the kind of stuff we're about to do. So I'm going to show you a few things on this one. We are going to use these commands in assembly. Don't worry about following them just yet. I'll just talk through what they are and I'll show an example, and then you guys will have a go at practicing one. So we are going to use a command called INP. These are all very short commands, and what that does is gets a value from whatever input source is in use and puts it in the accumulator. So when we type in INP, it will ask the user for an input, and that input will go to the accumulator. If you remember, the accumulator is a register inside the CPU that stores stuff while an instruction is being executed. We'll have out, which takes a value from the accumulator and outputs it to whatever is connected. STA will take a value in the accumulator and will store it into a memory location. So you put STA followed by the location, and it will stick whatever's in the accumulator in memory for later use. LDA is the opposite. It will load it from a memory address and put it back in the accumulator. Add and sub will add and subtract a value from the accumulator. So if we say add 5, it will add 5 to whatever is already in the accumulator. If we say subtract 2, it will take 2 off whatever is already in the accumulator. And then the bottom we've got some branching, which we'll talk through in a bit, and HLT is halt, which will stop the program running. And that's it. Those are all the commands we can use in this version of assembly. And that's one of the big things between assembly and a high-level language is we only have very primitive commands, and we have to get creative to make the program do what we want using just that small selection of commands. So I'm going to do a little demo with this. We're going to get an input and store it into memory, and that's all we're going to do initially. Now in a high level language we'd use something like this: num1 equals input. That's fine, we're used to that sort of stuff, but in assembly we have to use what we've got available. So we can combine two, if I can find where it's gone, two of the command, where have I put it? There's a table gone. We can combine two of the commands from here. We can use the input, which will put a value into the accumulator, and then we can use STA, which will take the accumulator and put it in memory. So that way we've taken an input and put it in memory. So by combining those two commands and then halt to finish, we will have done that. So we're going to, I'll just get Little Man Computer up. Oh, I had it ready to run. Why is it not there? Okay, let's get that. So I'll click the Little Man Computer link. There it is. Okay, so here's my Little Man Computer. Hope you can see it. It is kind of small, but there's not too much we can do about that, unfortunately. Okay, so this is how Little Man Computer works. You stick your assembly code in that far window and press submit, and it will put it all into memory ready to be executed. So let's have a look. So I put in INP, that's my first instruction, then STA50 is my second. Now there's a good reason why I'm using STA50. Remember, STA stores a value in a memory address, and I've decided to store it in memory address 50, which is down here. There's a good reason why I've gone for 50 and not started at 0 or 1. We'll have a look at that in a few minutes. Then once that's done, we're going to stop the program, so I'll put HLT as my last command. So a simple 3 instruction assembly program. We press submit, and if you watch up here before I press submit, at the moment 0, 1 and 2 are all 0. When I submit, those numbers change up here. I'll try and zoom this in so you can see a bit more clearly. There we go. Well, notice when I submitted it, the memory location 0 and 1 changed, and that's because these are the programming instructions. They are now converted into their binary equivalents and put into memory locations 0 and 1. So the first instruction was IMP, That's what 901 is. 901 is the code for input. The second one was STA50, and that's 350 has been stored here. So it turns out that 3 is the code for storing and 50 is the address. So 350 is the code that goes in there. Now 2 contains 0 because 0 is the code for halt. The rest also contains 0 because there's nothing in them, but that's how it works. 0 is halt. It's also the same thing if it's empty. So address locations 0, 1 and 2 now contain my program. They contain my code. This is why when I wanted to store a value that I'd inputted, I stored it in location 50. Had I have stored it in location 0, it would have overwritten the program that's already in there, because the program and the data share the same memory. And it's perfectly possible to accidentally overwrite the instructions with the data, and that would be catastrophic. It would ruin the program. So we've got to be very careful when choosing memory locations that we don't use memory locations that are already in use by the instructions. So I started with 50. That gives us 0 to 49 to use for instructions before there's any danger of overwriting it. And none of the programs we're going to write are going to have more than 49 instructions. Okay, hope that makes sense. Now let's have a go at executing it and see what happens. So let's zoom it back out. Zoom it in a bit more. And there we are, I can see that a bit better. Okay, so I'm going to run this. Now it runs slowly and shows what's going on with the program counter, the accumulator, the address register, all that sort of stuff. And I'll talk you through what's happening. So when we run, the first thing it does, it looks at the program counter and realizes that's 0. The program counter is incremented to 1. Remember, this is the fetch execute cycle we looked at in Unit 2. And that's sent along here to fetch the instruction in number 0, which is 901. 901 is fetched and placed into the current instruction register. So the instruction is 9, the address is 01, that's how it's split up. And that's now in there and it's executed. So it's executed 901, which is input. So it's asking me to type an input. So I'm just going to put any old number in. Let's go with 12. So I type 12 and that is sent to the accumulator. So 12 is now in the accumulator. That's the first instruction executed. So now it executes the second instruction by fetching it first of all. The program counter is incremented and the instruction in address 1 is fetched. So that's 350, which we now know is store in memory location 50. So that's sent to here. It's put into the instruction register and now it's going to be executed. And that tells it that to take the value in the accumulator, which is 12, to memory location 50. So there we are. 12 is now in memory location 50. We're now executing the third instruction, which is halt. So the program counter is incremented. The third instruction is fetched from memory location 2, which is 0. So 0 is taken back down and will be put into the instruction register. And then when it executes that and it sees a 0, it knows that's a halt command, so it will stop. So as soon as that's in there, execute it, and that's the end of the program. So that's what actually goes on inside a CPU when you're executing assembly instructions. Okay, so before I continue, has anyone got any questions about that? Is there anything you particularly want to ask before we go on and get you to have a go at doing a relatively straightforward task? Okay, I'll assume there's no questions coming through rather than it's just a very long delay, but if at any point you've got a question, please do type it in the comments. I will deal with it. I have to go in 5 minutes. How come? Well, I'm sure you've got a valid reason. Whatever it is, don't forget this is on YouTube. You can always come back and watch the rest of the lesson when you're done anyway, and I'd like you to do that because there is a task at the end of this. Okay, so let's carry on from here. So there's a task I want you guys to have a go at using Little Man Computer. So the first one here, create an assembly program that takes 2 inputs from the user and adds them together and outputs the result. Okay, so the first part of that, getting an input from the user, storing it in memory, we know how to do that. That's what we did on the previous slide. This whole slide is on the VLE, by the way, if you need to go back to it. So we can start with that, and that means one of our values have been there. We'll then need another input to put a second value into the accumulator. Or we may not even, yeah, we'll have to do that. So if we then go back to here, and you're allowed to look at these, you don't have to do any of this from memory, we have an instruction here, which is add. Oh yes, I got that. That's fine. Add, and it adds the number in memory location specified to the value in the accumulator. So if we have a number in location 50 and a different number in the accumulator, we can use add to add them together, and that will leave the answer in the accumulator. So you should be able to use add and then out to get the sum of them in there. So I'm going to ask people to have a go at that first. If you're completely flummoxed, give it a go. I'll go through it in a bit, but I bet half the class will probably be able to do this. If we go look at the second task, task 2, create a new assembly program that takes two inputs and outputs both the first number subtracted from the second and the second number subtracted from the first. So it does a subtraction both ways round. So to do that, you'll have to store both numbers in memory locations and then get one of them out and then call the sub thing, then get the other out and call the sub command, and see if you can make that work. Okay, so using Little Man Computer, can you have a go at these two tasks? If you're stuck, if you've no idea, stick something in the comments. I'll help you out with it, but I want everyone to have a go at it first of all. So if you have no questions coming through, let's give it a shot. Be kind to the student teachers, Ella. Oh, it's not student teachers. Be kind to the new teachers, Ella. See you later. Okay, right. Well, I'll leave you guys to work on that for a few minutes, and then we'll come back and see how you did. Okay, just to make clear, I'm going to ask some random people to paste their solutions to this into the chat. So if you think you've got the option of sitting there just not doing it and waiting for me to go through it, not an option. If you're stuck, you should be asking questions about it. If by the end of this you've not asked any questions, I'm going to assume you've been able to do it. If I then say post it and you say I couldn't do it, then that's you choosing not to do it and choosing not to ask for help, and that's not acceptable. So you have a go at this, ask questions if you're stuck. I'm going to ask people to paste their attempts at it in about 5 minutes time. Okay, also while you're doing this, just trying to finish off the register. The following people I've not seen in the chat, so if you are there, quickly post something. I've not seen Paige Kostick, Sean Dudley, Kieran Finch, Rebecca Hall, Sophie Holbrook. You may have posted and I've just missed it. Summer, Callum, Ewan, Jack, Rachel, Tommy and Cole. If any of you guys are there, quickly post something in the chat and I'll update the register. Sean, okay, thank you, Sean. Okay, thank you, Jack. Thank you, Tommy. Thank you, Summer. Okay, so still missing Paige, Kieran, Rebecca, Sophie, Callum, Ewan, Rachel, and Cole. If any of you guys are there, let me know. If you're struggling with chat or something, feel free to send an email. Just make sure you let me know you're here. Oh, Paige is here. Got an email. As is Cole. Okay, so Cole and Paige, I have got you guys. Okay, does anybody reckon they've done at least task one? Anyone got it to add together two numbers and output the result? How do you do the outputs? The out command, OUT, will take whatever is currently in the accumulator and will output that. Okay, a few people there with task one. Does anybody reckon they've finished both tasks? Got them both working correctly? If you have, just type both, because so you're not still answering yes to the previous question. So stick both down there if you finish both of them. Okay, most people still working on task two then. Okay, I'll give you 5 more minutes, then I'll come back and I'm going to pick someone at random to tell me how to do task one. If you're still not able to do task one by this stage, you need to be asking for help on it. Again, if the chat's not working, feel free to send it by email. I'll be checking that as well. Yeah, I think most people are still on with task two. Okay, so chat or email if you're stuck with task one. If you're okay with task one, I'm going to be asking some random people to post their code in about 4 minutes now. Okay, Jack, not sure about task one. Okay, well, the stages you need to do are, first of all, input a number and store it in memory location 50. Exactly the same as we did in the example on the previous slide. So if I skip back to that slide, there we go. So that code there will get an input and store it in location 50. We don't want the halts, that will finish the program, but those first two can be done that. You then need to do another input. That will put a different number in the accumulator. So now you'll have a number in the accumulator and a number in location 50. Then the add command will add a memory location to the accumulator. So if you do add 50, it will take what's in 50 and add it to the accumulator. And then you've added your two numbers together. So that's all that's really needed for it. Got a couple finishing with task 2, that's good. Well, let's see if it's seems to help. Okay, right. Summer struggling with the with the chat. That's fine. Right. There's several online Python things we can use. We'll worry about that when we do the Python stuff on Friday. This is a totally separate thing. This little man computer. Right. So yeah. So if you're struggling as well, just like Jack. Honestly, that step by step is all we need to do. We need to do an input and store it, which is already shown how to do here. The first line takes an input and puts it in the accumulator. That one puts the accumulator in location 50. Then you do another input, so we get a second number and put it in the accumulator, and then do add 50. That will take what you put in the location 50 and add it to the accumulator. That's all that's needed for adding. It's a bit simpler than I think a few of you thought it was. Tried to add 10 and 6 and got 907. Okay. Python 907 makes you think it's outputting an instruction somewhere. I've no idea how that's happened. Right, Devin, can you paste your assembly code into the chat? And we'll have a look at it and see what's happened. And then I'll go through one way we could do it. So I'm very intrigued to see how adding two numbers has got to 907. So if you just paste the whole assembly code into the chat, we'll have a look at how that's worked. Or yeah, if you I think you're doing the chat on your phone and the stuff on your computer, aren't you? Feel free to email it me instead if that's easier. Okay, right, this has come through from Devon. Right, let's see if we can follow through what's happened here that's come up with a really weird one. So you can all watch now, so I'll go through this and I'll get people to send me some correct working ones. Right, so this is what Devon just sent me, and we'll see if we can see what's gone wrong with this one. So we've done input, then store in location 50, then input and store in location 49, and then store in 50. So what you've done here is you've overridden 50, you've overridden what's in 50 with what was in the accumulator now. Then you've added, then you've stored again, then output. I think what we're trying to do here was actually, you were trying to load 50 and add it. to something. So let's go through how this would be done. I think a few people have got this working, but let's go through where we're up to. So you're completely correct up to this point here. In fact, you don't need to do that last one, so we'll do without that. Though it would be perfectly fine to do it that way. So we've inputted, we're stored in 50, I've inputted again. So let's have a look at what situation we're in after this. So let's just run this. You can speed it up with these arrows here, so let's go a bit quicker. So we don't need to watch all the animation every time. So it's going to get that. Let's do an input. So I'm going to put in 12. I'll stick that in the accumulator. And now it's asking me for the second input. So I'll input 6. And that's the end of the program. So 6 is now in the accumulator because that was the second input. And 12 is in location, is in location 50. So we've got the two numbers that we want to add together. One of them's in location 50 down here, and the other one's in the accumulator. So that's the situation we want to be in. Now, if we use the add command, and I'll go back and show you what the add command does according to this. So add adds the number in the memory location specified, so you have to give a memory location here, to the value in the accumulator, leaving the result in the accumulator. Well, that's exactly what we want. So we can type add 50. That says add 50, not the number 50, but the location 50 to the accumulator. So accumulator 6, it will add 12, because that's in 50, to it, leaving us with 18, which is our addition. So we'll test that, submit it, run it, step it up to full speed. We still have to wait for it to do the first fetch, and then it won't do it after that. So it's asked for our first number, 12. That goes into the accumulator and then also gets stored in location 50. So there's 12 in location 50. Then it asks for our second number. So I'll put in 6. And there we are. It went into there and then it added 12 to it to leave 18. And that's our 12 plus 6. That's worked. So if I finally go to out. Well, let's do it to be very fast. Default fast. And we run it. So I can put in 12, 6, and there we are. It's outputted 18. So that's all that was needed to be done for this one. We've got an input and stored it, got another input, and then added what we stored to it and outputted it. Okay? So, yeah, how many of you did roughly that method and got it working? A few of you may have stored it in 2 memory locations, then loaded one from that memory location to add. That's perfectly fine. It's just some steps that aren't technically necessary. But if you did that or my method and got it working, can you just let me know? So just Michael. Oh, and Jake, good. And William. And Rebecca. Okay. So quite a few people did manage to get that. That's great. Good. So if you got that, and if you didn't, hopefully you understand that as I went through and could do that now. Right, the second one requires you to take 2 inputs and then do one take the other and then the other way round as well without getting the inputs again. So let's just adapt this to show how we'd do that one. So we get input and store it in 50 and get another input. The problem is, if we now do our subtraction, it will overwrite the accumulator and we'll have lost our second input. We won't know what it is anymore. It's not stored anywhere. So we have to store the second input as well. So I'll store that in 51. So we'll test that. I'll quickly run it. Oops. Run. And I'll put in, say, 12 and 3. And there we are. 12 is in location 50 and 3 is in location 51. Good. I've got both my numbers I need to deal with stored. So now to do the subtraction the first way round, I'm going to load the first number and subtract the second. Then I'm going to load the second number and subtract the first. So load is LDA, load address. So I'm going to do LDA 50 and subtract 51. That will load what's in 50, so 12, into the accumulator, then subtract 51, which is 3, from it. There we are, and then we'll output it. Then to do it the other way round, I'll just do that in the other order. So I will load 51, subtract 50, and then output that. So that will load what's in 51, so 3 will go into the accumulator. It then will subtract what's in 50, so 12 from it. So if we take away 12, will be minus 9. So we should get 9 and minus 9 both being output. So let's test it. So it's asked for a number. So let's put in 12 and 3. And there we are, 9 and minus 9. It's done the subtraction both ways round. Okay. Any questions about that? It's an email question. Let's have a quick look. Oh, that's just Devon's code. That's fine. So if no questions come through, I'm going to assume we're all happy enough with that. Now, there is going to be some tasks on this to submit, so this isn't going to magically go away. So if you're not sure about it, you're better off asking. Okay, right. We've only got 5 minutes because of all the technical issues. Right, what I'm going to do, I'm going to show you this next bit. So the people that have got the hang of this have got something to work on. If you're not sure about that, I'm fine. We'll carry on with it next week anyway. But I do want to make sure those that have got their head around this want to have a bit of a challenge. Okay. Right, so next thing we'll look at is branching. So in high-level languages, we usually have things like ifs and whiles, which allow us to jump around the code and do different things under different circumstances. We need something to enable us to change the flow of the code in assembly as well. And for that, we use branching. And in this little man computer assembly, we have 3 branch commands. There's BRA, which will branch to a different memory location. So we can say, the next memory location you'll execute will be, and give it a number, and it will just execute that memory location. So we can make it jump anywhere in the code. So if we did BRA 0, it would go back to the first instruction. So we could make an infinite loop by having BRA 0 at the end. BRZ will branch only if the accumulator is currently 0. So it will look at the accumulator. If it's 0, it will branch. If it's not, it will just carry on with the program. And BRP will branch only if the accumulator is positive or 0. So it won't branch if it's negative. So those are the things we can do. We can also use labels to make branching easier. So we can get code like this. I think I've just got time to demonstrate this. So I'll demonstrate this and we'll see what it does. So let me just stick that code in. In fact, I'm going to be lazy and copy it from here. There we go. So there's my code for it. And let's have a look what it will do. I've used a label here. So I've said branch to the positive label, and there's a label called positive, so that's where it will branch to, and it's BRP, so it will branch only if the accumulator is currently positive. So let's run this and watch what will happen. So first of all, it asks me for an instruction. I've done this fast, it's fine. So I'll put in, say, 12. Now 12 is positive. So when it gets to here, 12 will be in the accumulator. It says branch if positive. It is positive, so it will branch down to here. It will skip the halt command and execute from there. So it will output 12. So let's run it and see if that's what happens. There we are. 12 has been output. That worked. But what happens if I put a negative number in? Let's run it again. Reset, run. And I put in -6. Well, in this case, that's input, so -6 will be in the accumulator. Then it says branch if positive to pos. It is not positive, so it won't branch. It'll run the next instruction, which is halt, and that will stop the execution. So it will never reach the output. So if it's a negative number, it will stop the program and it won't be output. So if we run this, press enter, there we are. The program stopped, but we have no output. So the branching allowed the program to continue only if we entered a positive number. If we enter a negative number, it stopped the program where it was. That's how branching works. And remember, we can do BRP to branch if it's positive, or BRZ to branch if it's 0. Those are 2 different conditions we can do. So the task, I want those of you that got the hang of this to have a go at, ideally before next week. And if you don't get a chance, don't worry, we're going to continue this next week. We lost about 20 minutes at the start of this lesson, so we'll catch it up next week. So first of all, this easy task, I want to write a program that plays snap, essentially. It'll prompt for two numbers and it will check if they're the same. Have a think about how you might do that with the things we've already used. If they are the same, it will output the number. If they're not the same, it won't output anything. So have a think about how we could get it to check if two numbers are the same using what we've done. It's not a new command. There is no check if it's the same command. We can do it with the things we've done so far. So I'm going to leave that with you as a bit of a puzzle. If you can figure out how you can use what we've done so far to check if two numbers are the same using things we've done and BRP, BRZ to do that. And then the very difficult one is to check for the difference between two numbers. So we put in two numbers and it showed us both versions of subtracting, one from the other or the first one from the second one, and we got 9 and -9. I want you to write a program that whichever way round you put those two numbers in, it will only give you the positive difference. It will always output the biggest, take away the littlest, whichever order you put them in. Again, I'm going to leave that as a challenge for you to figure out how to do that. Now, some of you, I reckon, will be able to absolutely be able to nail that without giving any hints. Some people will be stuck spectacularly on it. If that's you, don't worry. We are going to continue this next week and I'll give a bit more help on it, hopefully with fewer technical issues, because the stuff I did downstairs does seem to have fixed my connection issues. Okay, so that's going to be left there because that's the end of this lesson. It's earlier than I intended to be. If you did manage to get this work, you're welcome to upload it to the VLE. There's a place there to submit it, but next week we're going to carry on with this one. So let's head back out of here. Okay, right, so any last questions on anything we've done so far? Sorry, it's a bit of a disjointed lesson. We had those technical issues at the start, but I think we still got there mostly. There's no questions. Oh, we've got something in email. Okay, so someone's had a few issues. That happens. Okay, so yeah, we'll leave that there then. And I'll see you on Friday and we'll continue with the programming stuff there. So that will be on Teams because it's easy to do that way and hopefully we won't have the issues I've with Teams, but we've had issues today with this anyway. Although on Friday I'm in school, so we've got a better interconnect connection there. Okay, so thank you all very much. I will see you guys on Friday. What button does this?